Hey everybody, welcome back. We're gonna figure out part two here. Um, so we need to figure out the mass of the sugar in the chocolate chip cookies and add the chocolate chips to the sugar from the chocolate chips to that same mass so that we can convert to how many atoms are in our cookies. So the hint is convert mass to moles using the molar mass of the sucrose. Then convert moles of sucrose to sucrose molecules with Avogadro's number. Then convert sucrose molecules to atoms total. It's the same three steps that we did in the chalk lab. Now, that was a while ago, so we're going to work through this carefully here. I'll be posting this video, and you'll be able to link and check it out if you get stuck. After you're done with all that stoichiometry, I hope you did make cookies because you're going to deserve eating a cookie. And maybe you might even share one. All right, so here is a sucrose molecule. And a sucrose molecule has in it lots of carbon, those are the gray ones, lots of hydrogens, those are white, and lots of oxygens, those are red. And each sucrose molecule is going to have a combination of all those atoms. So if we want to get to atoms at the end, we need to count all of these. We need to know how many total atoms are in this. We're also going to need to convert from the grams of sugar to moles. So that information in mole view is on the information card. This is the formula of sucrose, and this is the grams per mole. Actually, this is atomic mass units, so this would be the atomic mass of one sucrose molecule. But if we have a mole of sucrose molecules, then it would be 342.3 grams. So we use those numbers to do the math for this. All right, so that was part one. This, we're going to use part one. We're going to use our mass of our sucrose here to get to part two. So if we start with 299.9 grams of sucrose, and that's just the sugar that is put in into the recipe, but there's some more sugar that's not from the white sugar or the brown sugar. This is from the white sugar and the brown sugar, right? But we put in chocolate chips too. So I found this website as well. And this is for 48 teaspoons. So for 48 teaspoons, there are 16 teaspoons per cup. So if we used 3 cups, that's 48 teaspoons. That's 720 grams of Hershey semi-sweet chocolate chips. And that would be 384 grams of sugar. So we're going to add the sugar from our chocolate chips to our recipe so that we don't miss any of the atoms that come from the sugars in making the chocolate chip cookies. Okay, so 384 grams from the chocolate chips. Right? Okay, so we're going to add here 384 more grams of sugar for a total of 683. Let's just round that to 684 to keep it a little simpler. We'll go 3 sig figs. 684 grams of sugar in our cookies. Okay. Now, just like the chalk lab, this is actually 3 steps. 3 conversion factors are needed to get from grams of the sucrose to how many total atoms we have. The first step is we're going to divide by the molar mass of sucrose. That's grams of sucrose per 1 mole of sucrose. And again, where do we get that number from? That number is from adding up all, that number, let's make that big. Whoa, too big. I'm bouncing around here on the screen. That number is from adding up the number of carbons, hydrogens, and oxygens, molar masses from the periodic table. So 12 times the molar mass of carbon, 12 times the molar mass of hydrogen, 11 times the molar mass of oxygen. And I can just look that up in lots of places too. It's called molecular weight as well. Well, this is for one molecule, but we can call this grams per mole as well. Just change the unit because it's equivalent. So anyway, 342.3 grams per mole is what we're going to use. Oops, let's put that up there. Okay, so that gets rid of grams, that gets rid of sucrose by our factor label method, and we have moles of sucrose. Every 1 mole of sucrose has Avogadro's number of sucrose molecules, 6.02 times 10 to the 23rd sucrose molecules. So that gets rid of moles and sucrose and gets us to sucrose molecules. And then finally, every 1 sucrose molecule which is C12H22O11, would be 45 atoms because 12 plus 22 plus 11 is 45, right? So 45 atoms of those 3 types per every molecule. So sucrose molecules goes away. All right, so now I can get out my calculator and do this stoichiometry. Oops, I can move the calculator. That will be helpful. Get it up there, a little bit out of the way. Okay, so 684 divided by 342.3 times 6.02 to the 23rd. So this E means times 10. And on my calculator, it's an EXP button. It's different on different things. Sometimes it's a big E button. And then times 45 atoms. So this is a lot of atoms, and I don't want to write down all these digits. I'm only going to use 3 significant figures, and if I put this into scientific notation, I can just say that this is 5.41 times 10 to the 25th. Atoms. So that's in all of the cookies, right? That's how many atoms in all of the cookies. If you divide by the number of cookies that you made, then you can find out how many atoms are from the sugar molecules in the cookies on average that you're eating, right? Divide by number of cookies and you can get in one cookie. And this times 10 to the 25th, really this number would look like this. We would have a lot of other digits, but we don't want to write all that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 places that we move the decimal. So that's atoms per batch, right? But you divide by number of cookies and you see how many atoms approximately are in each cookie that you might eat. And so that's kind of fun. You can give a cookie to your mom or dad and tell them how many atoms came from the sugar that they just ate. And that is stoichiometry. So if you want more information about any of this, there I am again. If you want any more information about any of this and you need help or you have any questions, come to the meet that I'm going to have in Flex. All right, thanks.